very quiet. I do not talk.
That's why the little smirk going on.
I am well behaved.
I didn't say just because you're vocal that you're not well behaved.
Oh, times pi. Let's see.
Yes. Okay, so now we gotta put it in simpler.
1.5 minus pi times 1.5 squared. Don't you have to use diameter?
And then now what you do is you can multiply this.
No, because if it's in
I guess
problem is
one and a
because
half.
when you get to volume to the volume formula, it's in it's in radians. I mean radius. It's a radius.
Radius. So what you just
I have them working in their workspace. They've been working on these two problems for a little while. If you want, you can go ahead and pause and try them yourselves. We're about ready to start discussing them.
times dH
But she still ain't chugging out the problem
Just
question.
plug in, wait.
Huh.
Just plug in.
Is there a reason that
Do you have that?
pi r
Yeah, it's
squared's
like size of
derivative
4
is 2
centimeters.
pi r?
So it's 24.
Oh, because you're taking a radius shape and making it
Find the
2D.
area.
So it's kind of like think of it as like a sphere.
Like decreasing the degree.
And you're like cutting it, and it's like bam, right?
Root of 416 times 3 is 48.
I'm not sure if that's
It's like-
exactly that explanation.
Because like if you were graphing something like if you're moving it down steps like for like polynomials, it's like x
You're
cubed.
going down a degree.
You're going down a degree.
So
So
you're
like
going from the third
if you're going
dimension
from
to the
dimension
second.
to dimension. It's not. That's way better explanation than slicing.
Times 5/8.
Well, slicing is helpful and useful, but
Yeah,
not,
but you'd have to slice
not
it
in dividing.
infinitely thin, which is impossible.
That's the point.
So what is she?
All right, guys, we're gonna start just writing givens and finds, okay? Let's see how the givens and finds went. If you have those, you have a direction to go. So,
What did I find is wrong? That looks so subtle.
So the water level.
but if you guys match, you made
But I
some
did not.
mistake. No, not.
No, I haven't gotten 45 to match anything.
Oh, got it.
So.
Times 5/8.
Yay!
So it's 16. 16.
Yeah.
I know 44.
6.5. And then you like.
So the height is dropping.
Multiply by whatever, so like.
The centimeters per second, yeah.
What's 8 times?
Pause, how'd the givens and finds go?
Good.
Good. Good. Any questions on the givens and finds? The side was moving, changing, so ds dt, or s prime.
What's 60 over 1?
Find the rate of the area. And then they gave us a formula, right guys? Yep. So couldn't we say A is equal to, now I'm going to write this a little bit different way. Remember, if you're dividing by a constant, you can actually rewrite it to be a little easier.
Oh, it's a cylinder, so it's just 0.
Wouldn't that be a little nicer?
Oh, look at that. That's
Means the same thing, put s squared over 1. This is just taking the coefficient, multiply by root 3 and divide by 4. Cool, that's multiplying by root 3 over 4. So then when we go to take ddt of both sides,
Oh, look at that. That was easy. Like, I don't know.
quotient rule would have worked.
I think
Quotient
so.
rule would have worked.
Wait, what?
At the end of the day,
Oh, what just happened?
oh, I just moved the coefficients apart just to make it easier and a nice power rule.
Oh, I could have just.
But you could have done quotient rule.
Yeah, I did get
That's
that.
why.
Bring down the 2, they reduce, you get root 3 over 2 s times ds dt.
What?
I'm sorry. My paper just fell, but it got stuck in the other desk like this.
It's like black magic. I don't know.
Well, I'm very sorry.
That's pretty
Very sorry, very
This
sorry.
is crazy.
So we plug and chug, right? There's some excitement going on. My one's joining the video. There's some excitement. Okay, root 3 over 2, all times 4, times ds dt is 5/8. If you want to include units, you can. 4 would be the side, which would be centimeters. And then 5/8 would be centimeters per second. Hopefully this makes sense with the units as well.
2 pi r.
So we end up with dA dt. That reduces to be 1 and 2.
Scribbled that out because
That reduces to be 1
are
and 4.
squared, so we gotta do times squared.
How we don't know DRDH?
Yeah, we do. Or we have Oh, it tells us. Or not DRD. Oh, boy.
Alright guys, let's go ahead and make the conversations whispers as people ask questions. Sarah, go.
So was there a way to do it without doing quotient rule?
The way that I did it without the quotient rule is I rewrote this to be root 3 over 4 times s squared.
Oh, you didn't do quotient?
No, but I could do quotient rule. I did power rule. Quotient rule would have said bottom v top, which would have been 4 times bring down the 2 root 3 s minus top v bottom. Technically there's a dsdt right there, which isn't super fun. Minus top d bottom derivative of 4 v 0, all over bottom squared. The 4 and the 4 squared would reduce, and then you'd have 2 root 3 over 4, which is the same thing that I got. I just reduced the 2 and the 4.
So how do you know when you're like when you can do power rule?
My trick is whenever you're dividing by just a constant, you can pull that into the coefficient.
Oh, okay.
Yeah. Whenever you're dividing by just a constant. Or if you want to think about it, if it helps you thinking mathematically, root 3 s squared divided by 4 is the same thing as root 3 s squared divided by 4, which is multiplied by the reciprocal, and so the 1/4 can just join the root 3.
Oh.
Couple different ways.
What was the answer?
5 root 3 over 4, aka letter B, centimeters
I got-
squared per second.
I got 5 root 3 over 32, but I don't know how, but something went wrong. So I'll say it was a B and I got a C.
You might have just not been able to simplify all the way.
I did not simplify right.
Or maybe you thought the 4 was down? or the
No, well, I tried a quotient rule, and I don't know how it went.
Yeah, you might have kept the 16 and then just not simplified.
I don't know.
And then kiddos, the units make sense, right? Because area would be measured in centimeters squared, time would be measured in seconds. Okay, now it's time for 45, the given and the find. A right cylindrical water tank, I'm just going to quickly show it. What do we need? We need R.
No,
Oh, sorry, just in general for us. R and H. Okay, a right cylindrical water tank with a diameter of, what do we have? So we have 3 feet across, all the way across, and a height of 6 feet. So the height of the container, the height of the container is 6 feet.
Oh, wait.
But then I think we have water, right? At what rate is the volume of the water changing when the water level of the tank is dropping? So somehow this thing is either evaporating or draining out. Maybe there's a hole, but somehow the water is draining. So even though there's a big ol' R and H, we also need to look at our shape and say, okay, well this has an R, and this has its own H. So maybe I'll take away this H, since we know it's 6. The container is 6. Let's just leave the H of the water, because he's the guy that I'm worried about. Not worried. Guy that I'm working with. Okay, so then our given, a right cylindrical water tank with a diameter of 3 feet and a height of 6 feet is being drained. At what rate is the volume? Okay, when the water level of the tank is dropping, I made that my H, the height of the water. So I would say in mine, dH dt, but you might have called it L, and you might have called this the level of the water. L, that's okay. I'm going to call it H, dH dt equals, why am I putting -4 inches per minute?
Because that's what it says.
Good, it's decreasing, it's dropping. I'm trying to find the rate of change of the volume, so dV dt, such that D equals 3 and H equals 6. And if D equals 3, what can I also say? What's R going to equal?
1.5.
1.5, just in case we need to think about that. What's the formula that relates V and H first of all?
Volume.
Volume. So I can go ahead and take my V equals area of the base, which is pi r squared, times height. But I think, Sean, you were the one that just started taking a derivative, right?
Yeah, I was just like, let's go.
Yeah, he was like, just go. For some others of you, you might want to think about the water dropping and saying, is there anything that's staying constant? Well, not the volume, not the height.
Oh, no. The radius is staying constant.
Some of you might have realized the diameter, aka the radius, is staying constant. So technically, do we have to keep him a variable before the volume?
No.
No. We could plug in. And why would that be a good thing?
Oh,
Easier.
that's nice. Shit, it's better.
If he has to be a variable, don't we have to do product rule?
Yeah.
But if he doesn't have to be a variable, and if we do get to just plug in, oh hey, r is 1.5, couldn't we just say this is pi times 1.5 squared h?
So dv/dt is equal to
1.5 squared?
times dh dt.
That's 3/2 squared, that'd be like 9/4, I think.
Of course, why is it always easier than it is?
Long story short, we don't need product rule anymore, because 9/4 is a constant and pi is a constant, which is pretty cool. So then I can just go ahead and take ddt. Now, Sean, what happened when you did the product rule?
Oh, it's just, she became a mess.
Yeah, true, but you had a dht and
I
h.
did.
But what else did you have that you were like, wait,
DRDT.
he got a drdt.
But
And then he had
she
to
shouldn't exist.
think about the model and say, oh, r's not changing, drdt is 0. So he plugged in 0 and that would work perfectly.
I
If you
could've
took the
just
derivative
erased
first.
her out. That was
It would
bad.
work.
That was bad math. Did not do well.
Oh, but it would have worked.
No, but no, I literally just went like, oh, she doesn't exist, so I erased her. I didn't plug in 0.
Oh, so you ignored her.
I ignored her.
Poor drdt.
That's what
But if you plug in 0, then it would have made it all right. And then he would have been left with just 9/4 pi dht or 1.5 squared dht. At which point, all we have to do is, what do we got? Find him given, plug in -4. So 9/4 pi times -4. If you want to do dimensional analysis, you can. You end up with, we already plugged in stuff, sorry.
What
This
were the
was
things?
1.5 squared, so this is inches
way.
squared. And this would be inches per minute.
Oh, so
Do we have to divide by 12? Because if it's feet, you have to divide by 12.
Pause. What's
I
the
know,
struggle?
the units kind of messed me up and I didn't want to think about
That's
it,
okay,
so.
but we have to think about it.
Oh,
So,
the answers are
question,
in
where did it
feet.
start going bad? Not in the answers. I mean, the answers give us a good, like, whew, man, we almost got that wrong. Pause. What was in inches?
So then the
Right.
answer is going to be like
What were
75.
these?
Feet?
Oh.
What did we need? Feet. So pause. We can handle this.
Well, you can
Technically,
do
we plugged in
differential
h
analysis.
squared, so we plugged in feet already. So we have feet squared right here. Can we multiply feet squared times inches per minute?
No, but just
Not
change,
nicely.
just change the inches.
Let's just
to
change
minutes.
this to multiplying. We need to get rid of the inches, right?
Oh, inches.
Then we'll be just
Oh,
fine.
man. I was thinking units didn't.
Then we'll be just fine. Yeah, but with feet and inches, we have to make them correspond. So then we're gonna go ahead and be able to simplify. The 4's do reduce. The negative is gonna stay. We have 9/12, which ends up reducing to be -3 pi over 4 feet cubed per minute. And our units are good, and that ends up being d.
So
We haven't seen a lot of them, but I did mention how units can need to be resolved.
Are most of them, do most of them have like a unit base?
Measure? Yeah,
Yeah.
usually. The ones that don't is like when you have a point on a curve, then sometimes they don't really talk about it. Sometimes they just call it unit per second. And then the equations where they just give you, do you guys have any of those in homework where they just give you like an equation, they tell you dx dt or dy dt and you solve for the other? Those ones don't really have units because there's no application really. They're not really explaining what's going on.
It's unfortunate.
How it goes. We got 2 more examples done in our workspace, which is good. In homework, I know that we have some questions, but we also have that handout that I gave you guys yesterday. Why is this not going over? There we go. With 2 FRQs. If you have homework questions, we're going to peek at them for a little bit. Okay? If you have homework questions, we're going to peek at them for a little bit. If you don't yet, let's put it this way. If you are working on homework and don't have questions yet, like you're doing really well and you don't, then start looking at this and start playing with, let's play with the cone one first. I think that's the one we're most familiar with. But if you do have homework questions, let's just pause on the handout. We're going to try and get into it for at least like 10 minutes or so today. But let's pause on the handout and let's go ahead and go. I have the book open. So I'm gonna come back here. I'm gonna insert a page really quickly. Oops, not there though. I want it up here. I'm gonna go to single page. All right, what's one of the questions that we have, cool kids?
Oh,
Yeah.
I have a question for 25B.
Okay.
And part B.
20, yeah, 25.
Number 20 I do have on the board, and I'll talk about him in a second. But number 20 is a good question. I totally agree. There's something tricky going on. Remember, I keep on saying that you're going to sometimes miss something. And it's not missing something in your reading, it's missing something in your past math that might come back to not haunt you, but be useful.
She's haunted.
Definitely.
Well, it's a good time of year to be haunted, right? So anyway, coming back. Dun dun dun, number 25.
Because it's Halloween.
It's Reformation Day, isn't it? Isn't that what we
Oh.
All Saints Day is November 1st, you guys. Get ready. We're gonna praise you.
It's the 500-year anniversary of Martin Luther.
Million. 95
I say
pieces.
100 like it was
You know, Mr.
Mr. Carmichael, Mr. Strike, all of them should be huge fans.
Oh yeah, it was like in the
I
1500s.
Strike will probably go.
1510 or 1517.
Kiddos, we're going to look at number 25 for just a little bit. But question, is there anything else you want to look at? I have room for one more.
Oh, definitely 29.
29?
And sort of B, like, what the heck is the difference?
And what?
No, like,
Oh, in 29.
for A and B, yeah, what the heck is the difference between the length of the shadow and the tip of the shadow?
Well, length would be the entirety.
I know, but like,
point.
no, like, I know that, but like, how do
Generally
you
means
find the
there's not enough
difference
math time to
from...
block out upon this.
Can I use this picture down here? Can you read number 29?
No, it's the top one.
I know it's for 30. I was just curious if I could use the picture.
No, because he's walking away versus towards.
Oh, okay.
Are you mean up?
Can we just like reverse them, like mirror image?
Just Control A and then
Control, yeah.
reverse.
But then the light post will go with them,
Oh,
and that's not good.
so we just got a splice.
All right, well, I'm not going to do all that right now. Anyways, okay. Let's have number 25, 29. Thanks for bringing it up. That's a great example. It's at the very end. We'll peek at number 20 before going to the FRQs. I'm going to go pretty fast. This is going to be on the video. So if you can't quite keep up, or if you just want to pay attention and then use this video tonight, these explanations, that's a great idea, okay? But try as best you can to be thinking through the problems on your own as I'm discussing them. So first of all, before we even start talking about 25, some of you haven't even seen that one yet, because you might have gotten stuck on 20 or something earlier. An air traffic controller spots two planes at the same altitude converging on a point. Dangerous, right? They fly at right angles to each other. One plane is 225 miles from the point moving. So here's, I think it's this guy, according to the graph. So he's 225 miles. At the instant that the guy spots him, but we know it doesn't just pause midair and just like chilling there, right? That's not going to happen. So this is just one instant of time. But he is 225 miles. We could call this x if you want. This distance, we could call that x. And moving at 450 miles per hour. How can I use that for my given for number 25, cool kids?
dx.
Yeah, dx dt. Well, just because I named him
Yeah.
x, you could have named him plane A, it doesn't matter. Bob would name it according to my variable. Dx dt is equal to, now question, is the distance decreasing or increasing?
Decrease.
So negative 450
miles per hour.
miles per hour. Okay, then they say, hey, there's another plane. He's up here. So that's my y, or plane B, whatever you want to call him. They say that when the guy spots him, it's 300 miles away from the point, moving at 600 miles per hour. So we also know d y dt. Now if these two pass the point at different times, we're fine. If they pass the point at the same time, we're in some pretty big trouble, right? What's the find that they're asking us to do? At what rate is the, this is for letter A, distance. So we could kind of name the find A. So d, what do you got?
ds.
Oh, they called it s,
They call it
okay.
S.
So ds dt.
Increasing.
And then what formula? Well, the such that is the instance, right? So x equals 225
Y.
miles. Are our units okay?
Yeah.
Yes.
Good. Whew. Sometimes they've not been okay on these types of problems and it's really messy. 300 miles.
Yay.
What formula did you guys figure out if we have three sides that we're working with?
Pythagorean.
Oh, yeah, so we have x squared plus y squared. Nathan, I'm just doing the whole thing because it helps with b. I don't know how else to do b. So then if we take ddt of both sides, have you guys gotten down to where I can just say 2x dx dt?
Yes, ma'am.
So then you guys keep going for me.
2y dt is equal to 2s ds dt. Who's us?
Okay, what do we got to plug in? We have x, right? So let's plug and chunk in. dx dt, we have that too. We definitely need a calculator for this. Our units are okay because we have on each of these, I think we have, yeah, miles, and then miles per hour. So we're good. Plus 2y we have is 300 times dy dt is negative 600 equals,
Who is she?
but what do we have?
A formula.
So we can find s on our own. Who already found s and what did they get? Sean.
S is equal to 375.
And for all of those of you who are like, wait, what? There's a relationship. So if we have x and have y, we solve for s using Pythagorean. Yeah. So we solved and got 375, no decimals, right?
No decimals.
Okay. Not that there shouldn't be any, there weren't any. So then we're good. We can go ahead and plug in that 375 right down there. Solve, solve, solve. Someone help me. After all this work, what'd you get ds dt to be?
Negative 718. Oh,
Uh-oh.
I got 750.
I got 750 and 318. It was an odd. Who's right?
I think it's 750.
I don't know.
I'm pretty sure it is. In the
I
back.
put it all in my calculator and I put the left side in my calculator and then I
That's
divided by.
good. I divided by
Right
2
side.
times 375?
Yeah, where's my count?
Pull out a 2 and everybody divides. Nothing else really simplifies. That would be nice. Tyler, you gonna double check?
Oh, no, I'm doing my own thing.
Helpful. Maybe I heard that way. Okay, now as I'm double checking, just to make sure, and technically what I would probably do is I would do a big old fraction. You guys know I'm hitting alpha y equals, right? Get a nice pretty fraction. I'm gonna type this whole thing in, and then I'm gonna put this in the bottom of my nice big old fraction, just to make sure everything's good. As I'm doing that, 2 times 225 times, I'll put a parenthesis just to be nice, negative 450. Can you guys read letter B?
How much
Because I'll be helping you in a second, but
does it take to the air traffic controller have to get one of the planes on a different flight path?
Oh.
But I don't see.
What if the distance was 0?
Yeah, it's like distance is 0, but where do you?
But
Negative
where would
750.
you put that in?
Yeah, I'm like, I got that. I was like, I knew the distance s is equal to 0, but do you plug that where?
But wouldn't 0 have to be x and y as well though? Because both of the planes have to be at 0. So then,
So that's what I'll.
so are we solving for s now? Oh no, s is not time, s is a distance.
the key is this one, right?
Okay.
This is how far apart they are currently. And this is the rate at which it's changing. Do they have an hour?
No.
No. They don't have an hour. So hold on, wait a minute. Isn't there a good old-fashioned physics formula called distance
Over.
equals rate times time?
Oh
Dirt.
my gosh.
Distance equals rate times time. But guys, don't worry, it's basically just dimensional analysis. We're saying they need to cover 375, they only have 375 miles of distance between them left. So I need to take that rate, the negative 750 miles per hour, and say, what time do I need in order to get 375? But another way of looking at that is I'm basically dividing or multiplying by the reciprocal. So 375 miles.
Build the bridge, get rid of what you don't want.
And I put the negative 750 down there with the miles, because I need hours. So you can think of it mathematically with a formula, or you can think of it as, well, I need the miles to cancel, I need the hours to stay, so I'm multiplying by the reciprocal of the rate. Sean?
But in the answer, it's going to be expressed as negative, but time can't never not exist. So do we express it as positive?
It was positive in the book.
Time, yeah, negative time is not the answer. It's, think of it this way. We're thinking of the speed, which we haven't talked a lot about, but speed is absolute value. So we're just saying like, hey, it's going this fast. We don't care that it's decreasing. We need to figure out how much time have we got to cover this positive distance.
Okay.
And a way to call it a negative distance, because it's decreasing to that. But The better way of thinking about it is we're thinking of the rate, not as in terms of velocity with the sign saying increasing, decreasing, but we're thinking about the speed, just the how fast. Yeah. Or at the end, you would actually take the time and be like, wait, not negative time, oh, absolute value, positive time, because that's how long it'll take. Tyler?
Do you have the answer for the windshield problem?
Somewhere. Who has the answer for me? What's 375 divided by 750?
30.
What was it?
0.5, so if that's hours, it'd be 30 minutes. Yeah.
Okay.
0.5 hours.
You could say 1/2 hour or 30 minutes.
That's a long time.
True, but there are other planes in the sky, so they figure out where to send them. I've heard the two highest stress jobs are air traffic. Where did I hear this?
Air traffic.
Air traffic
I can
controllers.
imagine though, because there's a lot
And-
of risk.
Yeah.
If you took the
And
planes
was it
down-
anesthesiologist? I think there's one that was even more. Air traffic controller, and I don't think it's anesthesiologist. What was that one?
A traffic cop who stands in the middle and directs cars.
But ironically enough, teaching was one of the top like 5.
Yeah, because you could be killing students permanently if you're not good.
All right, kiddos. We did number 25. What we didn't get to do is number 29. I'm going to go ahead and just cut him off of this page because, yeah, we need we need a whole nother page for him. So let's go ahead and insert a blank page. Let's insert another blank page. Okay. Yeah.
Could you?
Yeah. Hold on. I'll bring it up on this computer back here.
Here's my math.
Guys, start reading number 29. It's the shadow problem.
6 feet tall is 90% for the B, for the ground. And he is 10 feet from the base of the light. Tip of his shadow. What is it? Where you felt the light of the shadow moving. Like, what is the difference? Is it the tip moving at the same rate as the light? Huh. That's fun. I'm like,
I need to draw this out. Hold on real quick, I need to draw a light bulb.
Alright, picture. 6 feet tall. Man is walking away from. So we have a light pole. If you want, you can put like a little light on top. I just, whenever I do that, it never turns out well. Here's our little stick figure. I'll make him kind of long and lean because he's 6 feet. And as the light shines, there's a shadow. So here's the shadow. And he's walking away from. He's walking away from the light. But here's the tip of the shadow. Okay, so let's label what we have. We know that the light is 15 feet above ground. Is that changing? Is the light changing? Nope. We know that is for sure. What else do we know for sure? He is
6 feet tall.
6 feet, and him walking away from the light pole is not making him get any shorter or taller. But what is changing? His shadow. And ironically, the speed at which he is walking is not the same as the speed at which his shadow is changing. Interesting. So how do we deal with this? I see 2 different right triangles, don't you guys?
yes.
All right, we need to label some stuff. So we could have this, the smaller right triangle with the man and the shadow. We could call that x, right? The 6 feet, I think that's constant, so we're not even going to call him a variable. We could call this hypotenuse if we needed to. We could call that, like, I don't know, z, c, something. But then we also have the longer version.
Plus X. Because if he's 10 feet away,
Yeah. So then one way of saying that is like, okay, so we need to kind of talk about this other guy also, so maybe we'll call him y, so we can call this guy x plus y. And to be honest, we could do the exact same thing here if we wanted to. We're running out of letters here. Maybe we'll just call him a. There we go. Z plus a. The ironic thing is we actually don't need all of this. I'm just showing you all the different things you could label in a triangle. I'm not dealing with angles because it doesn't even say anything about an angle, so forget that. We're just looking at sides. We have a smaller triangle and we have a bigger triangle. Okay, so let me get a highlighter really fast. Here's our smaller triangle. And here's our bigger triangle. Alright. When he is 10 feet from the base of the light, at what rate is the tip of his shadow moving? Let's figure out our givens and our finds. So, given, find. Here's the tip of his shadow. All right. A man 6 feet tall walks at a rate of 5 feet per second away from a light that is 5 feet above the ground. So what are we given? We have the 6 feet, that's true, but we already plugged it in. We have the 15 feet, that's also true, but they did give us a rate. And walking away, okay, well, what can we say?
dx dt
Close, but it's not dx dt. Dx dt has to do with his shadow changing.
dx plus y? No, but that wouldn't work, because that's the entirety.
dy dt?
dy dt. How fast his distance from the light pole is changing.
Okay.
dy dt is equal to 5 feet per second. And since it's growing, we can say a positive 5 feet per second, right? Since it's growing, we can say a positive 5 feet per second. The tip of the shadow, I know it's weird, but the tip of the shadow, think, as he moves, remember, this is only one instant in time. As he moves, this entire x is growing and shifting. This entire triangle ends up shifting because as he moves, his shadow grows. So actually, dx dt is the shadow. Because as he moves, the shadow now is suddenly longer. Longer, 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 right? So this whole entire triangle is moving. This is just one instant of time.
Oh, and y.
And how that x is changing is saying how fast the tip of the shadow is extending. So we're trying to find dx dt, and we do know that, I guess we can say, that the man is... Oh wait, when he's 10 feet from the base of the light, I know y is equal to 10. Now here's where it gets tricky. Have they talked about z and a at all? Have they talked about the distance from the light to the shadow?
No.
So all of this didn't matter. All they're talking about is how fast he's moving away from the light and how fast his shadow is changing as a result. So what on earth kind of equation uses only two sides and not the hypotenuse and there are no angles involved?
Yeah, I have no idea.
Can we pause and look at number 20 for a second? Number 20, water was going into a trough, which had the shape of a triangular prism, a triangular prism. This is number 20. Now I'll take a picture of this before you leave, because it'll definitely help. Do you guys see the red similar triangles on the left-hand side? Everything should pretty much kind of flow naturally, out of the problem. Based on, like you guys with the multiple choice problems we did today, these facts should kind of naturally flow, but they gave us an H and didn't give us a B, and if you realize after I plug in, I actually had to take 1/2 base times height for the area of a triangle, multiply it by the width. It's kind of like pi r squared h. I had to find the area of the cross-section of the base and then multiply it by the extension. The trough is always 12 feet, I think, 12 feet long, so I was able to make that a constant and plug in. But the problem is I had a B and an H, and all they gave me stuff to deal with was H, so I had to go looking for B myself. But there was no other obvious formula that related B and H unless I looked at the picture and I saw, wait, the container is 3 across and 3 deep. So if it's 3 across and 3 deep, and if this shape of the container, the water's going to conform to and be a similar triangle to, the sides of similar shapes are proportional. Which means if the width and if the height, or if the base and if the height are 3 and 3, then this little one, the base and the height, they're going to be equal also. Whatever level the water is, the base and the height are always going to be, if the base is 3 and the height is 3, well then I can make a little proportion and say, oh hey, cool, that's 1, base equals height. So I could come down and to try to resolve Sean's problem, I'm going to plug in first, then take the derivative. Now, oh, dv dt, a little derivative, dh dt, psh, I'm ready to plug in and solve. But the geometry that we missed, Anna and I were working on this one, the geometry that she missed, that was the whole clue or the whole key for the problem, was seeing that similar shapes have proportional sides. Do we have similar shapes up here?
Yeah.
Yes.
Yeah. We have similar shapes. Because angle, the angles are congruent. Similar shapes have proportional sides, which means our formula could be 6 over 15. One side that we know with respect to the other side that we know is equal to, well guys, we need the x's and the x plus y's, so what would be of the smaller triangle, what would be the base? X. And what would be the base of the bigger one? That's our formula. Now, as it's written, that's disgusting. But what if we cross multiply? And what if we get 6x plus 6y by distributing, right, equals 15x? Oh. And what if we do one better, and what if we get all the x's on one side, so 6y equals, subtract the 6, 9x?
Let's do it better. 6 divided by 6.
Oh, we're going to do it?
We're going to do it. We're going to get fractions.
Ugh. All right, divide by the 6 and divide by the 6. Y equals 3 halves x. Hey, let's take a derivative, yeah? That's the whole point. ddt. We didn't need Pythagorean. We didn't need trig. We could just use similar shapes have proportional sides. That's all we could use, actually. So dy dt is equal to 3 halves dx dt, which, after we plug and chug the 5 feet per second, we can go ahead and say dx dt is equal to 5 times 2/3, and multiplied by the reciprocal to get rid of the 3 halves, to get dx dt alone, because he's who I wanted. And we end up with dx dt equals 10/3. I think this is measured in feet per, I don't remember. Oh, seconds. Check your units, but they all measure up.
So we didn't use one.
We didn't need y because it was a constant rate. Sometimes you need it, sometimes you don't. Depends on the derivative. So this one problem helped you not only with the shadow problem, but also with the trough problem. Similar shapes have proportional sides. So if they give you two sides and their relationship, I can use that in the smaller similar shape. Like in this one, they gave me one side each. They gave me one side each, but that was still enough. I could still set up a proportion with the corresponding sides of the similar shape, or you could do something I did over there saying base to height is 3 to 3. You can set up different proportions. But long story short, you can use either the bigger proportions of the container, even though the water's not filling it up all the way, to show the proportion or the ratio of the smaller sides, or you can use corresponding sides to figure out the ratio or the proportion of the other corresponding sides.
Wait, that's B though, right?
Mhm.
That's B, the, like, 29B, because that's the whole one, that's dx dt. Or is it A? Like as in,
Oh, as in the part of the problem? I don't remember. Oh, I wasn't even reading. That's for A. So the only thing that's going to change on B, you can still use pretty much everything, but what have they given instead? Find the tip of the shadow moving versus I solved B.
Yeah,
I did the
like
length of
that
the
one.
shadow. The tip of the shadow would be the entire thing. Ah, poop.
maybe x plus y.
That's B. I should have named Y the other guy. Well, that's no fun. I should have named this one Y. And then that would have been,
X plus.
hold on, this one's good for B. This one's good for B. Because dx dt is the length of the shadow. I wrote tip and I just wasn't even thinking about it. For A, what would change? We have the same given, right? I would just redraw the picture a little bit. I would still have your 6 and your 15. I would still have your x. That would mean this y. So you're trying to find dy dt. Given that, ooh, I would just change that altogether. They gave us this one, we need that labeled as something. So then this would be y minus x, right? there we go, given that dxdt is equal to our 5 feet per second, you would still use your 6 to 15, but you would need to use the y minus x to y. There you go. That's what would change. So we need to make this one variable so we can state his rate clearly. And then I need this one to be one variable so I can state that. So this is for the tip of the shadow. From the light. How fast the tip is moving away, not from the man. That's how I got it wrong. The tip isn't moving away from the man, the tip is moving away from the light pole, like the man is. That's how I switched it. So this would be for A. Okay. Kiddos, hold on. Let's let's gather our thoughts. We have a test on Friday. We went over a lot of the trickiest problems from section 2.7 today. You were supposed to attempt it last night, get stuck, and now today hopefully some light bulbs are kind of going off. You're like, oh, okay, I think I can go back and hopefully keep attempting. This is the 2.7 homework. Now there is a chapter review. Tomorrow is pretty much a work day. This FRQs, I should say, these FRQs are great AP practice. There should be right past here somewhere. They're great AP practice, but they won't necessarily prepare you super well for the test. Since the test, I'm not necessarily making an AP level test. Like it is with multiple choice, it is with long answer. There are going to be some related rates. This will be good, and I will probably go ahead and tomorrow show you that I'm posting the questions and the answers online. But I think as a class, we probably won't look at this until after the test. It'll probably be homework for Friday night over the weekend to see how you can do.
Oh, yeah.
It is worthwhile.
Oh, some people can just say, I don't know how to do it and get full credit. Oh, Miss D, no.
No, they should attempt it over the weekend.
I got those. I got my units wrong. So 1 point.
But not too bad?
Yeah, I got the numbers.
The windshield one's just tricky because you have to use that time that's not specifically in your formula.
The W prime of 35 was because it was at, if it's increasing, like I didn't think about if it's increasing, I have to find that.
Right.